Hi friends, let's have a look at problem 2523, closest prime numbers in range. In this video, we're going to explain how to use Eratosthenes sieving method. So before we do the problem, let me first make a comment. So for most of the leetcode problems involving prime numbers, so they typically can be solved by sieving and by prime decomposition. You can see our channel for more practices. So now let's focus on the current problem. So basically we are given two positive integers. One is left and the other is right. So we want to find two integers num1 and num2 such that they have an order relation. Num1 is less than num2 but in this range. And they are both prime numbers. So we want to find the smallest gap between the consecutive numbers like num2 and num1, right? So here, if no such number exists, so we're going to return -1 and -1. So if you look at example 1, so let's see. Example 1, so we have from 10 to 19, right? So we know 11, 13, and 17 and 19 are actually all prime numbers, but the gap here is 2. The gap, this 2 is 4, and this is also 2, but we need to return 11 and 13 due to the problem requirement. So we need to consider consecutive ones, because if you compare 11 and 17, for sure this distance is larger than the distance between 11 and 13, the consecutive ones. So with that said, actually, we just need to find a way to effectively find the prime numbers in between the bound, and then we just do a linear scan to get the minimum gap, right? So now let me first do an edge case. So an edge case is if right is less than 3, say. So if right is less than 3, so even between 0 and 3, you have just one prime number, that is 2. Therefore, in this case, you should return -1, -1. So this is just one way of doing the treatment. You can absorb this case into the generic logic, but let's first pick out this case. And then what left us is to find prime number in a bound. So here I'm going to find a prime number in between, say, 0 and a prime number, any arbitrary number n, right? So this way, actually, we can do a lot of things. So here, what I'm going to do is the so-called Eratosthenes sieve. So let me write Eratosthenes. So basically, you're given an upper bound. So I want to find the outer prime number that is bounded above and then by n, that is less than or equal to n. So first, let's write, say, for n in this set 0 and 1. There's no prime numbers, so actually we can just return. But here because we want to do some checking, so we can see just return this. That's just for for convenience, because if n is 0, so you just return this. It make not good sense. Also, if n is 1, you return this. But let's just use it. So now for generic case, so first I'm going to initialize a array, so n plus 1, right? So what we do is that we first set a0 and a1. So this index corresponds to numbers. So the index is from 0 up to n, right? So first, these two are not prime numbers, so we're going to set it to be 0. And then we're going to use the sieving method. So for I in range, so we just need to start from 2 and then ending at mass square root of n, right? So but if n is not a square number, so I'm going to make it an integer first, and then I'm going to add 1. So the gap will be So let's see. This is the first range, because we don't need to consider larger ones, because the largest, if a factor is greater than the square root, roughly, then the other should be less, right? So then first we are going to see if AI is still 1. And if this is the 1, and then we're going to do this for g in range. So we start from I square, right? So this actually is a refined version of the original Eratosthenes sieving method. So ending at n, right? So the gap each would be something like this. In other words, I square plus some number times I is impossible to be a prime number, because I is a factor, right? So for those, actually we are going to set ag to be 0. Then after this sieving, the ones remained with a label 1 will be prime numbers. So we just need to return a. So notice here what we return. So no matter what, the returned a will be at least length 2, right? So now I'm going to call this function, right? How do we call that? First is to get the prime table. Let's see, prime table. So we call, let me, Eratosthenes. So this will be the right? And then we want to find those primes, primes in between. So the primes, so will be for for p in range with at least left, right? From left to right, can be any other right. So if prime table p, it means if this guy is a prime number, so we are going to do primes append p, right? So then what do we do? So we get all the prime numbers in between. Let's see, let me make some annotation. Get all primes in between left and right. So now what do we do? First we do a check if length of this guy is less than 2. So we do not have a good gap, so we can get -1, -1. And this is the one case. And then another case is that we can find the gap. So we can, because we are going to find the minimum one, I will start is positive infinity. And then I also get the end idx. So I will set it to be dummy -1. And then what I'm going to do is for I in range, so starting from 1, so that I can look at the previous one, and ending at the length, let's say n, length of primes. So then the current gap would be primes I minus primes I minus 1, right? So then you just need to compare if the current gap is smaller than the previous gap. So if current gap is strictly less than gap, so we're going to set the gap to be the current gap, and then the end index would be current index I. So if the current gap is exactly equal to the previous gap, we don't need to do the update because of the requirement for the return, right? So now what we do is this. So we just need to, because we have at least 2 numbers, so we must have a good return. So the 2 number would be primes, so end index -1, and primes end index. So this will be a solution to this problem. Let me check it to see if we write it right. So list out of the bound. So let me see here, prime if prime table, let's see, if right for p in range. Let me look at this function. So we get for 0, 1, so what we wrote is 0, 0, 1. Yes, so this is right. And then so here we have 1 times this is also right. So now prime table we have right. Then for p in left and the index plus 1, then for if prime table, let me see. Let's see. We're going to append p if this length prime primes append this. Let's see. Let me first run this. So list index out of range. So prime table, it means prime table there's some problem. So here we call prime table, and let's see, for n, I see here, if, right? Now let's see. It passes the first two test cases. So now let's look at the generic case. It passes all the cases. Here, let me, actually we can even assume, here, assume n is greater than or equal to 2. So we don't need this line, because that's not very elegant. The reason is that we have already checked if rate is less than 3, right? And then so here we just consider the case when n is greater than or equal to 2. So this will also work. I guess with this comments set, that's about it for the current video. So actually there are some advanced theorems concerning prime numbers. So, but for LeetCode problems, it might not go into that depth, because after all we are practicing coding. But it's good to know how to do this Eratosthenes sieving, and also given an integer, so how to do prime decomposition. So you're welcome to check out other problems in our channel. Thank you for watching.